Thank you, Robothon organizer, for allowing us, Team RoboTechX, Middlesex University, Dubai, to participate this year. This year's challenge is very challenging because we have a task board. We have to press the blue and red button, and then we have to determine if it's the red button or if it's the blue button that is lit up, and we have to determine that. Also have to pick up the stylus, which has two ends. We have the magnetic here and we have the stylus here. We have to draw something, depends on what appears over here, or we have to do some tasks depending on the text that appears here. We have to navigate this ball to go like simulating human tracing this, and there are three checkpoints here, three sensors that we have to pass through, and then finally we have to put this back. It's very challenging.
We are using Epson VT6 successor for our project, where we have the linear kinematic gripper, a carbon gripper. We're using Epson RC8 and the Python. We have two cameras. One camera is detecting the two buttons here, calculating the word coordinate through TCP/IP connection, sending to Epson, where Epson is translated into local coordinates so it can react and see the whole task board. The second camera is the 4K camera, where it's gonna go for the screen, detect the shapes and text, and then after that will act accordingly and draw with the stylus.
Hi, my name is Sydney. I worked mostly on perception in our solution. The very first camera module, which is a webcam, is mostly used to detect between the blue and red buttons, and we need to figure out the state when it's on. Because when it's on, we need to click on one of those buttons, whichever button comes on. The other camera, which is a 4K camera, is used to take a picture of the screen that's here. We're using Tesseract, which is an open source module. With all of this put together, the perception of this cameras actually give the Epson robot a good orientation of where it needs to go to.
Hello, my name is Bituskarya. My prime responsibility was in designing and manufacturing the end effector system for this robot for the given task. The key components, including the face plate and the gripper back plates, were manufactured using Onyx material, 3D printing using a Mark II printer. Other task what I carried out was the interfacing of this end effector system with the robot IUs. We specifically allocated a few IUs to control the gripper system. That's pretty much my part on this task. Thank you.
For the Robothon BYOD challenge, we bring our 3x3 slider puzzle board, which is from our childhood time. And this is the electronic version. It's very easy to randomize. Just press the button and it will make a random arrangement. The task of the robot is to figure out the sequence and move those tiles electronically by touching them. This camera is taking the picture of the layout of the board. This is a live view, and we can start capture, and then the robot will figure out, try to solve the problem. It is solving the problem right now, and I think it's found the solution, and it will start moving. Okay, it starts from there. So it moves around the tiles in the empty spaces in sequence. I think it found about 20 something steps and moves. Looks like a few more moves. Okay. And it's done. Puzzle is solved once again by the robot. Thank you.